All right, we're diving into 4.5, graphs of sine and cosine. Learning objective. You'll be able to graph transformed. The key here is transformed graph of sine and cosine. Sine and cosine. But before we get there, we're going to have to start off with sine x. We've got a nice little graph over here, already plotted out for you, or started out, and cosine as well. Let's go ahead and start with sine x. To do that, we're going to need our 5 critical values, which on the unit circle are the quadrant angles. So I'm just going to list these out. Next one is pi over 2, then we have pi, and 3 pi over 2, and 2 pi. I'm going to avoid these for a second. I'll talk about those after we get through with these. Awesome. Remember, sine on the unit circle, I'm just going to scribble this for a second. Sine goes with the y value. I'm going to draw that in black. Sine goes with the y value in the unit circle. We're just concerned about the quadrant angles when graphing this. So at 0 on the unit circle, sine is 0. Also at 2 pi, it's 0. And at pi, it's 0. At pi over 2, it's 1. At 3 pi over 2, it's negative 1. We can use that in our plotting. Now, if this is in terms of pi, it is convenient to set up your axes in terms of pi as well. Notice we have an increment of pi over 2. Pi over 2. I get the idea. So I can write pi over 2 here, and then pi, and then 3 pi over 2, and then 4 pi over 2, which would be 2 pi, and we can go ahead and finish it out as we're here. 6 pi over 2, which would be 3 pi, and 7 pi over 2. Whoa, where did that 8 come from? Probably because the next one's 8 pi over 2, which is 4 pi. And we have negative pi over 2 over here. All right, if you do not have to scale your y-axis, you don't need to write anything. So let's continue. I'm going to change our color to red. So we have 0, 0. Let's plot that point. What I like to do is do it the first and the ending of one cycle. Now, a little mention about a cycle. What we mean is when the values repeat. If I go around a complete circle, it's going to repeat here. And then again, and again, and again, and so forth. So we're going to see something repeat, in this case, a wave. 0, and then 2 pi is when it repeats. Halfway between those 2 points, notice sine crosses at 0. Between those two, it crosses at 1, and then negative pi. Now, all of these values in here, when graphed more precisely, actually look like this. Now, since this is talking about the vertical distance of a point inside of a circle moving around, the values are going to repeat. So the next one, as you saw from over there, is 5 pi over 2. And then we have 6 pi over 2, which is 3 pi. So 5 pi over 2 and 3 pi. 5 pi over 2 goes with the 1. And then the 3 pi goes with the odd or the 0. But you can just use the symmetry when you've already started your first period. By the way, this is called first period to here. And it's just going to repeat this over here. So notice this is 4 values. So this will be 4 values. So 1, 2, 3, 4. And then, excuse me, where that came from. 1, 2, 3, 4. I'm going crazy. Same thing over here. 1, 2, 3, 4. And then notice, since this occurs twice, this is going to go every 2. So 1, 2, 1, 2. And if I go back, it's not there, but I do have 1 here. And I can just draw a smooth sine wave between those. That's it for sine. Now it just comes down to making sure that you notice some things. Note that the period occurs between 0 and 2 pi, the first period. And these are called the critical points. Critical points. In fact, let's write that here. In fact, there's 5 critical points, and when I'm grading this, that's what I look for. 5 critical points. The distance away from what we would call the oscillating axis is called the amplitude. The A is this. It's the same thing over here on the downside, but I've got a lot of stuff written, so I can't write it. So we've got period and amplitude. Later on, we'll have a shift, horizontal, and a vertical shift. Because the learning objective, if we come back over here, is how the sine and cosine graphs are transformed. Awesome, let's go to cosine. I'm going to do the same thing. In fact, I would like for you to go ahead and pause the video, try out the cosine, and see if you get the same graph as me. Actually, I went ahead and just plugged out the values. You should already have your graph over here if you were able to figure it out. But I want to emphasize a few things while I'm here. Notice cosine starts and stops at the highest point on the unit circle. In this case, we'd say on its amplitude. So at 1 and 1 here, halfway between those values, it goes to the -1. Then it crosses the x-axis between these two values. Note this graph looks exactly the same as that, just shifted over some. All right, so let's go and draw a smooth sine wave here. And then let's continue using the kind of ideas of symmetry. And then it's 1, 2, 3, 4, 1, 2, 3, 4, and we just continue to graph. Should curve a little bit actually. All right, that's cosine. Critical values, critical points are those first 5 points within the first period. Same thing as from before. All right, let's go down to example number 1. Key points to sketch a sine wave. Now I've got a table here. I want to create a table here on this one, but we're not going to need to create a table every time we do these. So let's go ahead and start with our first quadrant. In fact, I'm just going to worry about the first quadrant and use the key points to sketch the rest of the curve. So we got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember, the unit circle, sine, is the y value. So whatever that output is with sine, it's going to be multiplied by 2. And if it's got this distance, it's going to go up 2. That means its amplitude is going to change. Go ahead and erase that so it's not too sloppy. So on the unit circle, when the angle is 0, y is 0. It means it's 0. If you remember, halfway through, it's 0. At pi over 2, sine is at its highest. What's going to be twice that value? So 2 times that would be 2. 3 pi over 2, it's going to be twice that value. It's going to be down -1, so it's going to go down -2. Notice on this graph, I've given you 2 values because that's necessary. And we're going to go to scalar axis by pi over 2 and plot the graph. All right, so I've got the first period. Notice that the amplitude used to go up to 1. Now it's shooting up to 2 because of this number out in front. So I can use the symmetry to finish the graph. And that's what I get. Let's go down to example number 2. Notice we're asked to sketch both of these graphs on the same coordinate plane. I've already got a coordinate plane set up to be able to contain both of these graphs. That's a skill that you're going to have to be able to create and be able to have later on, is be able to take just blank graphs, equations like this, and be able to create their graphs. Now I'm going to use the ideas of the key concepts from before, the key points, to shorthand this. Remember that cosine starts and stops on its axis, or its amplitude, excuse me, whereas sine starts and stops on the oscillating axis. So, shorthand, we would write it like this. Sine x looks like this. Cosine x, as you saw from above, it looks like this. Starts and stops on the amplitude within the first period. Using this concept and the fact that the 5 key points occur here, here, and here, and here, here, there, there, and there, I can use that with these new amplitudes. Notice the number out front is called a. So in this case, a is equal to 1/2. And it's the absolute value of it, because it just tells us the distance away from the oscillating axis. All right, so cosine starts and stops on its axis. I'm going to go ahead and scale this by pi over 2. All right, and it's going to start on the axis. And I'm going to put 1/2 right here, because that's the amplitude. Starts and stops on its axis. Unfortunately, I'm running out of space there. Draw the curve, or the wave. All right, and then continuing that over here. That is the 1/2 cosine x. Change the colors for this one. This one starts and stops at 3. Because remember, cosine starts and stops on the amplitude. Right, and then halfway between those 2 points, it's going to be the negative value. And then crosses the same place the other one does. All right, and let's continue. All right, that's it for example number 2. Let's go to the next one. All right, we have a period of 2 pi over b. This will become more apparent later on. when we get down here, but for now, let's go ahead and accept this. Now, I just want to work with it for one example, and then we'll work it out down here. B is the number multiplied by the input, in this case, x. So B is equal to 1 over 2. The period is equal to 2 pi divided by that. Well, 2 pi divided by 1/2 is the same thing as 2 pi times 2 over 1, because dividing by a fraction is the same thing as multiplying by its reciprocal. That means that its period is now 4 pi. Now, to give you a better sense as to why the period is done this way, let's think of this. Whatever this input was, the output of x over 2 is going to become the angle for a unit circle angle for sine. So whatever x is, it has to have 2 times the value to be able to handle this, to have go back to the sine on the unit circle. Maybe it'll become more apparent when we get to the translations of sine and cosine theory down here. All right, with this, I'd like for you to go ahead and write out the increment. This is not something that the textbook does. And I'll abbreviate this INC later on. Now, if you notice from the critical values from before, we have 5 critical values. Let me go ahead and zoom over. Critical points, there are 5 critical points, but there are 4 divisions inside of those 5 critical points. 4 divisions, and that's key. 4 divisions in a period. Go ahead and scroll over a little bit. So if my period is now 4 pi, then I just take my period and divide by 4 to get my increment. Some teachers don't teach the increment. I think it's beneficial to build a graph more efficiently and effectively. Notice the increment is pi, so I'm just going to count by pi's. That's what it tells me. And then I have negative pi and negative 2 pi. And I'm going to use the what I've already learned about the sine wave. Remembering this is what's in my mind. Starts and stops on the oscillating axis. I'm going to use that, but its period is 4 pi. Starts and stops halfway through, up, up. Same thing over here, just like this, just continuing. The amplitude is 1, that's the number multiplied in front. The B changes the period. Now, I'm just going to sketch this in green. I want you to sketch the original sine wave in relation to this one. Remember that it starts and stops on its axis, and then it goes up halfway between those values. So in green is the original sine wave. Let's just graph one period of it before we move on.